Question 2. Aluminium oxygen cells are being investigated for powering vehicles. The reactions at each electrode are shown below. So we've got two half equations there. The standard electrode potential for the oxygen hydroxide redox system is plus 0.4. That's this one. So I'm going to just put that on there for a bit more clarity. Plus 0.4. And the standard cell potential of an aluminium oxygen cell is 2.71. What is the standard electrode potential of the aluminium redox system in this cell? All right, so this is a slight variation on a normal cell potential calculation. So you've got to be careful. The value here is the cell potential. That is the difference between the oxidation and reduction half cells. So this is your unknown this time. You're looking to figure out the standard electrode potential of one of the half cells. So it's not just as straightforward as taking your positive electron and taking away your negative one, because you don't know what the negative one is. That's your unknown. So let's treat this as an algebraic problem. Let's say that my unknown is x. And we know, therefore, that in any cell, it's always going to be the positive electrode minus the negative electrode. Just put it in brackets so it looks a bit more clear. So your positive electrode minus your negative electrode. And your positive electrode is always the electrode showing reduction, because that's the one that's more likely to show reduction based on the electrode potentials. So it's your reduction half cell minus your oxidation half cell. That's why I mentioned in the lesson it's a good idea to make sure you remember more than one way of recording this formula this formula, not just recalling positive minus negative. Make sure you remember that also means it's the reduction minus the oxidation. Okay, so in this case, the reduction minus oxidation will equal 2.71. Now the reduction half cell is the oxygen hydroxide half cell. That means it's going to be 0.4 minus our unknown x equals 2.71. So rejig it around a little bit. Now I'll do it the long way around for the non-algebraic mathematical people. So we want to obviously want x on its own. So I'm going to do this. I'm going to say 0.4 equals 2.71 plus x. So I've moved it from this side over to that side and made it positive. Okay, and now I want x on its own. So it's going to be 0.4 minus 2.71 equals x. So if you work that out, the answer comes out at minus 2.31 volts. So there's your answer. Okay, so be very careful on these ones. It's very easy to get the sign wrong if you do the algebra the wrong way around, or if you just misread the question. All right, very commonly answered incorrectly. And part 2, construct the overall cell equation for the aluminium oxygen cell. So in this case, you've got the two half cells already written, the half equations written in terms of oxidation and reduction. So it's just a simple combination of the two. You've got to make sure you equalize your electrons out, so cross multiply the number of electrons to make them the same to balance the charges, and then it's everything on the left and then everything on the right. Cancel down what appears on both sides. So as I've got 3 electrons in the oxidation equation and 4 in the reduction, if I multiply the top equation by 4 and the bottom equation by 3, that will then mean my electrons and my charges will balance out. So then I'm going to combine everything on the left, all the reactants, and then everything on the right, all the products. So it's 4 aluminiums plus 4 times 4, 16 OH minus, plus 3 O2, plus 3 times 2 is 6 waters. Electrons will cancel, so I'm going to move them out. Will give me 4 aluminium hydroxides, plus 3 times 4 is 12 OHs. Okay, so there's the overall equation before I've cancelled things down. So you can see I've got hydroxides on each side, 16 over here, 12 over there, which means I can remove the hydroxides from the right-hand side because they're all going to go, leaving me with just 4 OHs there. So there should be your final overall equation. 4Al plus 4OH minus plus 3O2 plus 6 waters will produce 4AlOH4.